Today we're going to talk about applications of quadratic functions. First, I want you to remember that all quadratic functions have graphs that are parabolas. Every parabola has either a maximum or a minimum value, which is the y-coordinate of the vertex. To solve application problems involving quadratic functions, you need to model the equation with a quadratic function by defining a variable and writing an equation using the facts of the problem. So we're going to start with this one to illustrate. A rectangular dog pen is constructed using a barn wall as one side and 60 meters of fencing for the other 3 sides. Find the dimension of the pen that gives the greatest area. So the first thing we're going to do is we're going to write the dimensions of the pen using the amount of fencing available. So you're going to have to make my width x and figure out what the other 2 sides are. Press pause. When you're ready for my answer, press play again. So as you can see, I made my width x, and then my length is going to be 60 minus 2x because I had 60 meters of fencing. And the next step is to write an equation to represent the area of the pen based upon the dimensions. And I have a rectangle here. Remember, the area of a rectangle is base times height. So write the equation to represent the area now. Press pause and play when you're ready. So you can see I took my width and I multiplied it by my length and I multiplied through by x, and then I changed the order because I wanted it to be written in a way where my highest exponent was first. And the next thing I'm going to do is notice that it's quadratic, so it's going to represent parabola. This negative leading coefficient represents a parabola that turns downward, which means I'm going to have a maximum, and that's a good thing because that's what I'm looking for. The maximum is going to occur at the vertex. So I'd like you to find the vertex, noticing that this is in standard form, and we have a really nice formula to find it. Press pause. When you're ready for the answer, press play again. Okay, so the maximum occurs at the vertex. We're going to find the vertex opposite b over 2a. So b was 60, so it's negative 60 here, over 2 times negative 2, because my a was negative 2. And I find that x is 15. To find the y value of my vertex, I simply plug 15 into my function. To find that's 450. Now, it's really important to write your answer in context. 15 is the number of meters x is. 450 is the maximum area. So we're going to write a sentence making sure that we're answering the question asked. Find the dimensions of the pen that give the greatest area. And I'm going to add one thing to it. I'd also like you to mention exactly what that greatest area is. Write your sentence. When you're ready for the answer, press play. Okay, so this is what I wrote. I said a pen that is 15 meters by 30 meters will produce a maximum area of 450 square meters. Notice that I put the dimensions with each of these. The dimensions are important when you're answering an application problem. The 30 meters I got by taking 60 and subtracting 2 times 15. Okay, here's another problem. A ball is thrown into the air so that its height, h of t, is given by the function h of t equals 30t minus 5t squared at any given time t, where t is measured in seconds. After how many seconds does the ball hit the ground? Think about the height when the ball hits the ground. How far off the ground is it? Part B says after how many seconds does the ball reach its maximum height? And part C says what is the maximum height of the ball? I'd like you to give this a try. Press pause. When you're ready for the answer, press play again. Okay, so what I did was I set my h of t equal to 0 because it's going to hit the ground. When it hits the ground, it's going to be 0 feet off of the ground. And one thing I noticed right away is it did not tell me the units. So I guess 0 units. To solve this, I factored out a negative 5t. I found that t was equal to 0 or 6. Obviously, the ball, after being thrown, it's not going to hit the ground 0 seconds. It's going to hit the ground 6 seconds later. Part B says, how many seconds does the ball After how many seconds does the ball reach its maximum height? That occurs at the vertex. So opposite b over 2a is my x value of the vertex. I plug in 30 and negative 5. So opposite of 30 over 2 times negative 5 is 3. It's going to reach its maximum height 30 seconds. After 30 seconds. Part C says, what is the maximum height of the ball? We plug in 3 to h of t, find it's 45 units. Whether that's feet or something, I don't know, but 45 units. Okay, so we just looked at modeling application problems off of a quadratic. This problem is a little bit different in that we're going to be given some data and we're going to run some regression. I know in the past you guys have used regression to find linear equations. We're going to use the calculator to find regression equations that are quadratic. So let's take a look at this example. Tim throws a football into the air at an initial height of 6 feet. The table below shows the estimated height of the football at various times during the path that ball followed. So we're going to answer a few questions first. So here's my time in seconds and my height in feet. I want you to try to answer this. Between what 2 times do you think the ball reached its maximum height? And what do you think that an estimate of the maximum height would be? Press pause. When you're ready for my answer, press play again. Okay, so I said it happened between 1.5 and 2 seconds. I noticed I hit 15 here, which was the maximum of all these y values. So I said somewhere between 15 and 13. It's probably it could even be 15, but I said that's where it would be. And I guess just over 15 feet. The next thing I want you to do is I'd like you to plot your data onto this grid. I made my units on the horizontal, half seconds in time, and my height, 2 feet for each unit. So I want you to plot that. I want you to decide which is the independent variable in y and decide which is the dependent variable in y. Press pause. When you're ready for the answer, press play again. Okay, so I have my data plotted. The independent variable is the time. Height depends on the amount of time that has passed. The dependent variable is height in feet. That's for the same reasons as 4. Height depends on how much time has passed. Now, the next question asks, enter the data into the list menus in your calculator and run a quadratic analysis. This is actually what I got when I ran the quadratic analysis. We're going to do that together. Here's my calculator. So, to enter the data into the lists, you're going to press Stat, and then option 1, Edit. Now, if you have data in your lists that's not correct, you can tab up and press Clear, and then Enter. Mine is correct. I've already entered my data. In your L1, you're going to put the times. In your L2, you're going to put the heights. And you'll notice that I've entered those already. Press pause. When you're ready to proceed, press play again. Okay. Once you've gotten your data entered, you're going to quit out of that menu by pressing second quit. And then we're going to run the regression. So to do that, you would press Stat, tab to where it says Calculate. You are going to then choose Quadratic Regression, which is option 5. And your X list is your independent variable. So that is in L1. If that's not already entered, you would press second and then number 1 for L1. Your Y list is your L2, your dependent variable. And I like to store the equation it produces. So to do that, I'd like to put it in my Y1 of my equations. So I would press vars, tab to where it says Y vars, and choose option 1 for function. And I put it in Y1. Now we're going to tab to where it says calculate. Now some of you may have an old calculator. that does not have an X list and a Y list. For you, you're still going to follow the same procedure, except you do not need to enter L1 and L2. You will just get the quadratic regression function will display on your home screen. And then you can still put in the equation you want to put it in into your Y1 by pressing the same keys as I did to get store regression equation. So you would do vars, Y vars, and then choose the function, and then Y1. So now I'm going to press calculate, and you can see that it produces my equation. So it shows you the form. My leading coefficient is negative 2.262, which is what I have written here. My B value is 7.464, written that there, rounded it to the nearest thousandth, and C is 6. So that is my regression equation. Now, I had it store my equation in my Y1. I want to show you how that works. So I would like to see on my calculator all of my data points and also how my equation looks. To do that, we're going to turn on a stat plot. So you'll do second and then Y equals. And option 1 is the stat plot. Make sure that you have on highlighted, and then tab down. Make sure you have these dots highlighted. That will show my scatter plot, my data. And my X list is L1, my Y list is L2. I have it blue, but it really could be anything. So now we'll quit out of there. Now we're going to press zoom, and we would like to zoom stat. And it'll set up a really nice window for us. So as you can see, I have my data points drawn on there, and I have my parabola drawn. And my data points were all just estimates, values, and this parabola is estimating the height the ball takes at any point in time. Now, we'd like to use the regression equation. What's the approximated maximum height attained by the ball? What's the maximum height attained by using the regression equation, what is the approximated maximum height attained by the ball? Number 8 says, what is the maximum height attained by the ball? Do this using the maximum function of the graphing calculator. After how many seconds does the ball hit the ground? Number 7 and number 8 are really asking something very similar. What is the maximum height attained? Okay, well, try to answer number 7 using your equation. Remember, the maximum occurs at a vertex. We're going to talk about number 8 in a moment, and try to answer number 9. Remember that it's going to hit the ground and the height it would be when it hits the ground. Press pause when you're ready for the answer. Press play again. So, I see what it was to do. So, to find the maximum height attained by the ball, I used opposite b over 2a, and I got 1.65. My y value I got by plugging that into my equation, and I got 12.158. I wrote, according to the quadratic regression equation, the maximum height is 12.16. I rounded differently. Number 9, after how many seconds does the ball hit the ground? I set it equal to 0, and I solved. Now, I'd like to pull out my calculator. Hold on, let me get it. Now, if I have graphed this already in my calculator, I can find the maximum height like this. So let's press graph. I'd like to find the maximum. Second, calculate. You choose maximum, which is option 4. And then it says a left bound, so I'm going to go to the left of where I know that maximum occurs. I'm going to enter, and then I'm going to do a right bound, right of where I know that maximum occurs. And then I'm going to guess, and it's not important that I guess really closely, but it should be in between the left and the right bound. So there's the 12.115.8. Okay, so that's really nice, but I will get the same thing by doing opposite b over 2a. You'll notice that's my 1.65 that I already found. Now, really nice, if I plug in 0 for y, I can solve for x. I got 3.97 seconds, but I can also do that on my calculator, and this is how. I'm going to press second calculate. I'd like it to find the zeros. Remember, the zeros are where I cross the x-axis. So I'm going to go to the left of my 0. And now I'm going to go to the right of my 0. And now I'm going to guess. And you'll see that it happens after 3.97 seconds. That's how I got it on my calculator. So that's the lesson for today. Have a great day. Check out my assignment online. Give it a try. We'll talk about it again tomorrow.